So welcome back. We're going to move into what we call two-step equations. So again, we have this equation concept of a right side and a left side. And with equations, typically what we're trying to do is find the solution, solve for x, get x by itself. So what I want to do is find the solution to each one of these equations. And also again, we're not really, when we say solve for x, what that means is get the letter by itself. In this case, the letter is m. I want to isolate that. Some strategies we can use is to get this by itself is I can kind of use what we call the zero pair concept, and then I can think about multiplying and dividing last. Remember, with an equation, our thought process is there's a right side and this left side. It's clear that the right side is a 6. On the left side, we have 2 times some number, which we don't know what it is. I got to subtract 4 from and get 6. So there's my sentence. 2 times some number has to equal 6. We have to keep it balanced. So I know this is already down 4. So what I got to think of is what can you subtract 4 from and get 6? If you think about that, 10 minus 4 is 6. So what you ask yourself then is, how could I make that a 10? Well, 2 times 5 would be 10, and 10 minus 4 would be 6. So I'm thinking that my solution should be a 5, because that would make the right side and the left side the same value. So if you just look at it as a sentence, you're trying to figure out 2 times some number minus 4 has to be 6. And again, we don't know what this is because it depends on what we pick for our value. But I do know that this has to be 10 because 10 minus 4 does give me 6. And if I put a 5 there, 5 is going to make a 10, and that's going to make a true statement. So again, if I can think that in my head, I've done my work, I just write the answer down. M would equal 5 in this problem. I'm moving on to the next question. Now, if our mental skills really aren't prepared to do all that, we can do it in steps. So again, what we're trying to do is work our way to this letter M. The first thing we always go after is we kind of go after the adding or subtracting part. It's like the order of operations backwards. So again, since we're using inverse operations, we actually go after addition and subtraction first, and then we go after the multiplication and division second. So this is always our first thing we go after. Our second thing we usually go after is that multiplying and dividing. So zero pair, and then our multiplication and division. So I'm going to zero out this negative 4 by using its opposite, which is a positive 4. But remember, in equation thinking, whatever you do on one side, you have to do that on the other side of the equation. So I need to add a 4 over here. I'll draw a line to say, let's now work it out. I do know the 4 and negative 4 are going to zero out, so I just go ahead and just mark that out. And there's really no math to do except to bring the 2m down. On the other side, we have 6 plus 4, which will simplify down to a 10. Now, since this is connected with multiplication, 2 times what number is 10, all of a sudden say, wait a minute, 2 times 5 is 10. You may be able to see the answer at that part. So m would equal 5. We also, since that's multiplication, you can kind of go backwards and say, well, 10 divided by 2 would give me my answer of 5. Now, if I'm using equation thinking, since I see multiplication, that's a signal to me to divide each side by 2. You may remember doing it that way back in school. So these 2's go out, divide 2, it goes into 2 one time, so it gives me my m. And 10 divided by 2 does indeed give me my 5. And that's how I can actually solve it using strategies. So let's look at this next example. 5 minus 7 has to equal negative 7. So again, in my equation thinking, I've got a negative 7 over here. I have 5 times some number minus 7 equals negative 7. What I pick up on is this side's negative 7. I kind of see that there's a negative 7 here already. So if this part can go away, negative 7 is going to equal negative 7, and I'm going to be there. But what can you multiply a number by to make it go away? Well, if you pick 0, 5 times 0, that's going to zero out. It's going to turn to 0. And 0 minus 7 is going to be a negative 7. So 0 would be the solution to this problem. So don't forget, 0 is a number. It can be a solution. Okay. So I can just write down m equals 0, and I can move on to the next question. Now, if I want strategies, our strategies is focus on the addition and subtraction part first. So I focus on this minus 7. Again, I'm trying to get the m by itself. So I'm focusing on the side that has the m. I want to zero that negative 7 out, so I put a plus 7 there. But to zero that out, I have to also put a plus 7 over there. So whatever you do one side, you must do that to the other side of the equation. this -7 and 7 zero out, I have 5m is equal to, and -7 plus 7 actually turns to 0. So that also zeroes out. So, but I got to put a value there on that side. That 5m kind of takes care of that on this side. Now, to get m by itself, we can divide each side by 5. Those 5's divide out, and 0 divided by 5 is 0. So our solution would indeed be 0. So again, when I say solution, that represents our answer. What makes it a true statement? So 0 would make this true, because 5 times 0 minus 7 does give me a -7. So let's look at this next example. Again, I want to find the solution to this problem. Again, what we can do is using our steps, 0 pair, multiply or divide. Let's see what we have here. So notice how we have this -3 here. I can zero that out by adding a 3. That -3 and +3 divide out. I have x over 4 now is equal to, and a -3 and a -10 and a +3. A -10 and a +3, that 3 is going to take off some debt, but I still have $7 of debt in there. So notice how that becomes a subtraction problem, and it stays negative since it's more negative. Now we have to find x, but we can also see that this is division. In division, we know we can use multiplication. So I can actually get rid of this dividing by 4 by multiplying by 4, as long as I do that on both sides of the equation. So these 4's divide out. 4 goes into 4 one time. That gives me 1x, which we write down as x. And -7 times the -4 does give me a -28. So -28 would be the solution to this problem. -28 divided by 4 is -7. A -7 and a -3 would indeed give me a -10. So it does make that a true statement. And that's what it's all about. We're trying to make that statement true. That makes it balanced. So I have m plus 5 over 4 is equal to 10. Now this is a little different. Notice that I really have this division that's causing some complications. I have this fraction, if you will. Fractions, if we can get those out of the way, that's going to make the problem a little bit easier. So what I can recognize is I have a division of 4. That it's a good idea to take care of that division first, actually. So this one kind of breaks our rule up here. Since this is a fraction, let's get rid of that 4 first. And I can get rid of that 4 first by multiplying each side by 4. So I'm going to use parentheses to show multiplication. But we do know that this 4 does go in this 4, and they just divide out. That just leaves me my m plus 5 over here. And this math over here, 10 times 4 is going to give me 40. And then, you know, what plus 5 gives me 40? You should be able to see probably that 35 there. 35 plus 5 is 40. 40 divided by 4 would give me 10. So that does check out there. But again, if we want to use our 0 pair, we can zero out that positive 5 with a -5. So I have a 5 and a -5, they zero out. I have an m, and a 40 and a -5 would give me a positive 35, and that would give me my solution. So that was a little bit different because of that fractional language there. This one looks a little different too. What I can do though is, we've seen this before, when I see a number outside of parentheses, I can actually use that distributive property to rewrite that. So I'm going to go ahead and bring that 2 through the parentheses. So 2 times n is 2n, and 2 times 5 would give me my 10. And then I have that -4 on this right-hand side. So on this left side, I can kind of rewrite that, removing the parentheses using the distributive property. Now this looks like something we're familiar with. That looks more like this type of equation. So now I can kind of go after that 10 with the -10. I can zero out that positive 10 with the -10. That 10 and negative 10 zero out. My 2n would slide down. Equal sign slides down. And a 4 and a -10, a 4 and a -4 and a -10 would give me a -14. So a -4 and a -10 would add up to a -14. And then to get rid of this 2, since this is multiplication, I can think backwards and divide each side by 2. Those 2's would divide out, and that achieves my goal of getting that letter by itself. That's my strategy. And -14 divided by 2 would give me a -7. So that would be my solution. And I can kind of play with that. A -7 and a 5 would give me a -2, and 2 times -2 would indeed give me a -4. So you can always verify that answer, see if it actually does make it a true statement, by substituting that value back in and working it out. So you can kind of evaluate that expression, if you will, that we did a few lessons back. So that's kind of introduction to two-step equations. We probably will need more practice, but let's see where that takes us. Stay tuned.